Now we are moving to segment 3, that is MapReduce, related to processing model. So then we are continuing with our 11th topic, that is on MapReduce programming model. Coming to explanation, so this MapReduce programming model. Okay, so this is a method for breaking a problem massive data problem into two steps. This massive data problem will be into two steps across a cluster. So first step will be map step. So in map step, so it will filters and cleans the data pieces. And coming to reduce step, it aggregates and combines those pieces. Simple. A method. It is a method for breaking a massive data problem into two steps across a cluster. So in during map step, it filters and clean the data pieces. And coming to reduce step, it is going to aggregate and combine into pieces. Let us understand let us understand this particular MapReduce programming model with an IT example. Think of an IT asset, asset inventory count in a company. IT asset inventory count in a company. If company have if company is having 10,000 laptops over 4 global offices, not in single office, across 4 global office we have 10,000 laptops. And so you will implement this particular map phase. If you implement map phase over here, so there will be a script, runs at each office. Out of this 4 office, in each office the script runs independently. So for what? To list laptops and their status. For example, so as I said, 4 global office, right? So for example, consider Newark. So in Newark, 500 laptops are active. So in another global office located in London, so there 300 laptops are active, and so on. Other two examples. This is about map phase. Let us see about reduce phase. What happens in reduce phase? In reduce phase, there will be a central script. Okay, which combines four location list. So why we are combining these four company list to give them to give them this particular active laptops to the CTO as one final number. CTO as one final number, that is 8,000 laptops, 8,000 total active laptops company wide. In a map phase, we will get active laptops from each and every location. But in reduce phase, we will like try to come. We will have a center script which combines four locations to give the CTO regarding the final number of 8,000 laptops, 8,000 total active laptops company wide. And next topic will be on shuffle. The shuffle and sort phase in MapReduce model. Let us break down the simple explanation on shuffle and sort phase in MapReduce. So this is nothing but an automatic intermediate step between map and reduce. So before we are discussing about only map step and reduce step. So between this map step and reduce space, we have a automatic intermediate step. So we like it's not manual; it's an automatic intermediate step. So this particular shuffle and sort phase in MapReduce organizes all scattered data. It organizes all scattered data. Like if the data is scattered scattered randomly. Okay, so this particular shuffle and sort phase will try to organize all the scattered data. And after applying this phase, so it is going to ensure all identical items. It will ensure from the scattered data. It will ensure all identical items are grouped together and sent to correct reducer. So reducer is nothing but it will combine. Okay, so this particular shuffle and sort phase will ensure all identical items are grouped together and sent to the correct reducer. Let us understand it with an real-time IT example. Think of CI or CD, continuous improvement and continuous deployment pipeline. CI CD deployment pipeline. Okay, not with this, not this one. Let me change the example. So for this, like the shuffle and sort phase in MapReduce, let us take another example. Now think of a log management tool. Think of a log management tool. So like Splunk or ELTK, ELK. Okay. So this is used for sorting. This particular log management tool like Splunk or ELK will be used for sorting network logs. Okay. So here in this particular shuffle and sort phase in MapReduce. So over here the mapper pulls random server logs from everywhere, from everywhere. Okay. So this will be like mapper will try to pull random server logs from everywhere, and over here the automatic intermediate step, this shuffle and sort phase automatically organizes organizes error type. What are the error types? It will group all 404 errors. It will group all 404 errors together, and all 500 errors together. Together. And after grouping 404 errors together and 500 errors together, finally it will send each bundle. So 404 errors bundle and 500 error bundle to a specific analytical dashboard. To a specific analytical dashboard. Not only this particular shuffle and sort phase will automatically organize them, and end of the day it will send to the bundle for the specific analytical dashboard, for which dashboard it has to be displayed. For that particular analytical dashboard, it will send the info, it will send the data. Okay, that's about the shuffle and sort phase in MapReduce. Now we'll discuss about, now we'll move to the 13th topic, that is give me a moment. I will move to the 13th topic, that is MapReduce workflows. Come on, let's break down the simple explanation. This MapReduce workflows will try to connect multiple MapReduce jobs. It will be connecting multiple MapReduce jobs in a chain, one after the other, into a chain. So where the output file of job A becomes the direct input file of job A. So for multiple job reduced jobs in a chain, so like finally definitely the output file of job A becomes the direct input file for job B. So now let us think of let everyone think of this CI and CI or CD deployment pipeline. So over here, over here, job one scans scans the source code. So scans the source code repository for security bugs. And once job one finishes and outputs a clean report. Outputs a clean report. Once job one finishes and outputs a clean report, now now it will be with respect to job two. Now it will be with respect to job two. The job one finishes and outputs a clean report. Next job two will be job two triggers. When job two triggers to compile, so that approved code will be into a deployable doc, Docker container. When job one finishes and outputs a clean report, a job two triggers to compile that approved code into deployable Docker container. So this is the best example for MapReduce workflows. So by connecting multiple MapReduce jobs in a chain where the output file of job A becomes the direct input file for job B. Now we are moving to the next topic, 14th topic on advanced map reduce concepts such as partitioning, combining, and composite. Let us see it within a simple explanation. Let us see the simple explanation. So first we will start with the partitioning. So come to partition, nothing but in the MapReduce concept, it will be deciding exactly. It will like partitioning will decide exactly which worker node gets which specific key piece. So in partitioning, it decides exactly which worker node gets which specific key piece. And next coming to combining. So running a quick reduction. When combining, it will run a quick mini reduction on the local machine first to save network bandwidth. So to know the network bandwidth, it will run a quick mini reduction on the local machine first to save network bandwidth. And next, composing. So in composing, it will be linking multiple complex data jobs together. It will be linking multiple complex data jobs together. So in partitioning, it will be deciding exactly which like in partitioning, it will be deciding which worker node gets which specific key pieces. Okay. In combining it will run a quick mini reduction. It will run a quick mini reduction on the local machine first first to save to save network bandwidth. And next, composing. It will be linking multiple complex data jobs together. So in composing, linking multiple complex data jobs together, linking multiple complex data jobs together. Let us try to understand with an real-time IT example. So now everyone uh, global think of a global cyber security log analysis. Think of a global cyber security log analysis. Here you can able to see combining. Here you can able to see combining concept. So where a local security agent, where local security agent on a server counts, this particular local service agent on a server counts 500 failed login attempts. So with this particular local security agent, in combining this step on a server, it will count 500 failed login attempts. After counting the 500 failed login attempts, it will combines it will combines it will combines them into a so one summary note. It will combine into one summary note as 500 values from IPX from IPX. And before sending sending it over the network over the network. So in combining a local security agent on a server counts 500 failed login attempts, and after counting this 500 failed login attempts, it will combine into one summary node, that is 500 failed from IPX before sending it over the network. And next partitioning. Partitioning concept. Here the system reads so the IP country tag, that particular IP country tag, and so after reading the particular IP country tag, it will routes all European IPs all European IPs. If it is a European IPs, it will route to the EU complaints server. We will do to EU complaints server, and US IPs. If it is belongs to US IPs, US IPs to the US server. So which countries login attempts failure was happening for the particular country server, it will send the partitioning. And next, composing. And next, composing. So the job one. So in composing, the job one isolates the particular job one. It isolates suspicious suspicious IPs. It isolates suspicious. For example, job one, it isolates suspicious IPs, and the next job two updates updates the firewall block list. If isolating suspicious IPs, so in the job two, it will update the firewall's block list based on those IPs. Based on those IPs. Next, we are going to discuss about the 15th topic. 15th topic is on MapReduce job run life cycle. So definitely, like nothing but it will be classic versus YARN. That is another another resource negotiator. It will be comparison between classic and eight another like resources negotiator. It's in MapReduce run life cycle. So like this are nothing but classic versus YRN. There will be step-by-step process. There will be step-by-step process. So like for a job executing on a cluster, there will be step-by-step process for of a job executing on a cluster. So if you see it in the classic MapReduce, there will be one single bottleneck component. In a classic MapReduce, there will be one single bottleneck component. So that is nothing but a job tracker. It will did all it will did all the managing in it did all the managing, and in YRN, so in classic one bottleneck component job tracker did all the managing. In YRN MapReduce, the workload is split among specialized. Here the workload will be split among specialized decentralized managers to prevent crashes and scale larger. In YRM MapReduce, it will like the workload is split among specialized central decentralized managers to prevent crashes and scale larger. This particular MapReduce job run life cycle, nothing but classic versus YRN. There is the step by step process of a job executing on a cluster. In classical MapReduce, one single bottleneck component, that is a job tracker, did all the managing. In YR in MapReduce, the workload is split among the workload is split among specialized the workload is split among specialized decentralized managers to prevent crashes and scale larger. Now let us break down with an IT example, with a real-time IT example. So now here think of a agile agile project management. Think of agile project management. So what is going to happen if we choose classical MapReduce and yarn MapReduce? If we choose classic MapReduce, there will be one micro managing director, that is a job tracker. Particular one micro managing director tries to personally assign tasks tasks to every developer. Tries to personally assign tasks to every developer and monitor every single bug daily. If there is only one micro managing director or job tracker, which tries to personally assign tasks to every developer and monitor every single bug daily. So will be causing an administrative administrative logjam. This will be causing an administrative logjam. So let us see what will be with respect to yarn. With respect to yarn, so there will be a director. There will be a director. There will be like a director allocates like the director allocates budget budget or nothing but resource manager. But but each specific but each specific but each specific software project gets its that its specific software project gets its own dedicated dedicated gets its own dedicated Scrum Master. Nothing but application manager. In here it will be called as application manager, application master. uh, to run that to run that to run the to run that single projects new projects for a daily operations independently. So over here in in classical MapReduce, we will get one micro MD managing director, that is job tracker. It will try to personally assign. It will try to personally assign task to every developer and monitor every single work daily. And it is going to cause an administrative log jam. But if you use jam, if you use YAM, will be working as a director, allocates budget, like nothing but resource manager. But each specific each specific software project gets its own dedicated scrum master. So it will get for each specific project its own dedicated scrum master will be there, that we would call as application master in YAM. So this is going to run that single project, so that single projects daily operations independently, so that to run that single projects daily operations independently. Yeah, give me a moment. Now we are moving to the fourth segment. This will be on, this particular segment will be completely on Yarn cluster management. And we are discussing on 16th topic on Yarn architecture and resource management. Coming to the simple explanation. So this Yarn is a Hadoop's operating system coordinator. This particular Yarn is a Hadoop's operating system coordinator. So this particular Hadoop's operating system coordinator will features like resource manager, node manager, and application master. This architecture and resource management will features a resource manager. So this resource manager allocates global CPU or memory budget. So this particular resource manager will allocate global CPU or memory budget. And we have another, we were featured with another node manager. This node manager tracks hardware resource. It tracks the hardware resource usage on individual machines. It tracks hardware resource usage on individual machines. So tracks hardware resources usage on individual machines. This node manager tracks hardware resource usage on individual machines. And we have an application master. It coordinates tasks for one specific job. It coordinates tasks for one specific job. It coordinates tasks for one specific job. So Yarn is a Hadoop's operating system coordinator. It features resource managers. This resource manager allocates global CPU and memory budget. And we have a node manager. It tracks hardware resource. It tracks hardware resource usage. It tracks hardware resource usage on individual machines. And and an application master and an application master. So this application master coordinates coordinate tasks for one specific job. So node manager tracks hardware resource usage on individual machines, and application master coordinate task on one specific job. Now try to understand with an let us try to understand with an IT example. So everyone think of a Kubernetes. Kubernetes orchestrating orchestrating cloud containers. So here we will see these features: resource manager, node manager, and application master. So this particular so here the master Kubernetes control the plane that looks for cloud network. And after looking for cloud network, it decides how much memory is available. This is managed controls plane network, decides how much memory is available. And next we have node manager too. So this node manager is an agent. This node manager is an agent running on an individual running an individual blade server individual blade server individual blade server in reporting local CPU reporting local CPU temperature and RAM usage. And we have application master. This application master is a specific pod controller makes your corporate website container stays running. So with my example, we have a resource manager. So the task of resource manager will be controlling a plane and so to look after whole cloud network and decide how much memory is available. And coming to node manager, this is going to be an agent running on an individual blade server, and it will be reporting local CPU temperature and RAM usage. It will run on individual blade server It reports local CPU's temperature and RAM usage. And coming to application master, this is specific pod controller, so which makes your particular corporate website like website container stays running only. Okay? So we'll end up over here and we will have one more part